Okay, so lab one had to do with the charge tape. So, by manipulating and observing the behavior of adhesive tapes after they have been charged through simple contact and separation processes, we can study the interactions between positive and negative charges in this lab. This experiment familiarized us with the idea of charge as a property of matter, designing experiments using household objects, making estimates and simplifying assumptions, and the amount of excess charge on everyday objects. So, the purpose of this experiment was to prepare pieces of charged tape, observing their interactions, and determining approximately how much excess charge was on it using a computational model. So, the model, the free body diagram, as you can see here, the two forces acting on the tape were the electric force pointing up and the force of gravity pointing down. And some assumptions we made were that there was no air resistance. We treated the pieces of tape like point charges, and then we said that the charges on both pieces of tape were equal, and each U tape had about the same amount of charge and it was evenly distributed along the length of the tape. So, the fundamental principles that we touched upon in this lab, Newton's second law, which said that the change in momentum is equal to the net force times the change in time. The electric force was proportional to the charge and the distance between the two charges, and the gravitational force, which is equal to the mass times the gravity. So a preview of our results. Both pieces of charged tape repelled each other because they were both positive, and then we found the electric charge of the tape to be 1.25 times 10 to the minus 8 coulombs. So we defined our system to be tape A and tape B, the U tape, and our surroundings were everything else. So like the books, the table, our hands, and the initial conditions were the tape length was 20 centimeters or 0.02 meters. The tape charge was initially neutral, so 0 coulombs, and the tape mass was 0.02 grams or 0.0002 kilograms. So our experiment was two pieces of tape stuck on top of each other. The top piece was rapidly pulled off, thus becoming charged. And after charging two pieces of tape and holding them close together, they repelled each other. And the tape did keep getting closer to the table or any neutral object. And the tape was attracted to a neutral plastic pen after being rubbed in hair. So it had a negative charge. So we concluded that the U tape must be positively charged. So our calculations, the distance between the pieces of tape was 0.024 meters. The force due to gravity was negative 0.00196 newtons. So therefore, the electric force must have been 0.00196 newtons to balance it out. And then using the charge formula, we were able to calculate the charge on the tape to be 1.12 roughly times 10 to the minus 8 coulombs. And then this is the computational model that we used to calculate the charge. And as you can see here, we defined our charge, some constants, the distance between the two charged particles, and then here where it finally calculated the charge of the piece of tape, and then just a free body diagram of the two tapes as point charges. Some sources of error that could have come up, the pieces of tape probably don't actually have equal charge, even though we assume they did. Some charge could have been lost during the experiment, and then we also just could have measured it inaccurately with our ruler. What if electrons had positive charge and protons have negative charge? So the results of our experiment would still not change, since the tapes would still be the same charges either way, no matter how they were charged, and the pieces would still repel. Why is it important to handle the charged tapes as little as possible? When the tape comes into contact with other objects like hands, the electrons could move and transfer, resulting in a change of charge. So it could potentially charge your hands. And that's it. Thank you.